All right, so in this lecture, we are going to look at how to write the stereoisomers for E and Z isomers. Now, we are just going to practice questions because nobody will ask you to define E and Z isomers also. But if you are able to answer the question, then you gain an understanding from it in such a way that if any question comes out under this, you'll be able to answer it. Now, the question we have here says, draw and label the E and Z isomers for each of the following. Now, the first one we have there is is to tick. The first one we have here is CH3, CH2, then CH double bond, CH, CH3. Now, when you are given something like this, the first thing you do is to draw it in a way that you have the carbon-carbon double bond, and then you have every other atom arranged around it in such a way that you have four bonds around each of the carbons. So we are going to take this carbon-carbon double bond here, which is this one first, and then we are going to draw it here, something like this, C double bond C. And then the next we are going to have, this carbon is bonded to what? Is bonded to hydrogen and then CH3. So we are going to have it bonded to hydrogen and then CH3 here. And then this other carbon here is also bonded to hydrogen and then bonded to CH3, CH2. So we are going to have it as CH3, CH2. All right. Now, how do we now name this compound? Is this the E isomer or the Z isomer? Now, Ingold Prelog actually gave a rule for naming them by saying that we have to consider the individual carbon atom and then assign priority to each of them. Now, if you look at this carbon here, now looking at it very well, you agree with me that what is attached to this carbon here is what? Hydrogen, right? And what is attached here is what? Carbon. So in this case, this one, carbon has a higher atomic mass than hydrogen. Priority is assigned in accordance with atomic mass. Now, since carbon have a higher atomic mass than hydrogen, it definitely means that carbon will have the highest priority. One way I like to look at it is to give the highest priority group A and the lower priority group what? B. Now, coming here, the same thing. You look at this, carbon have a higher priority than what? Hydrogen. Now, if I want to arrange the priority here, I can say this is carbon, hydrogen, hydrogen, what? Hydrogen. That's the meaning of the CH3. Are you getting it now? So that at the end of the day, this carbon have a higher priority than H. So this one become A, while this one become what? B. Now, when the two high priority group are on the same side, and the two low, or let's say the two low priority group are on the same side, and the two high priority group are on the same side, it is the Z configuration. Is that okay? So this compound have the Z configuration. Now you may want to name the compound, but I will just give the configuration because that's what they expect you to do and not the naming itself. So this has the Z configuration. Now if you look at this compound very well, in case you want to name it, you can say this is carbon number 1, this is carbon number 2, carbon number 3, 4, and what? 5. Which of course you can call this compound as 2-pentene. You can say this is Z2-pentene, right? Or Z-pent2ene, because at position number 2 you have the double bond, right? So that is basically how to go about this. Now, have we done this? The next thing is, because the question says draw and label the E and Z isomers for the following. Which one did we just draw? The Z isomer. Are you getting it now? So we have to draw the E isomer. Now to draw the E isomer, all we need to do is come here, interchange one of the group. We can decide to interchange this one so that CH3 will be on top here, and then what are we going to have here? Hydrogen. Is that okay? And then here will still be hydrogen, and here will be CH3, CH2, right? So we use our I. I like dividing this into 2 like this. My invisible I. This one have a higher priority than what? This. This will have lower priority than this. So when the two high priority group are on different sides and the two low priority groups are on different sides, you call it the E configuration or Entgenge. So this is E configuration, or in short form, you can call it N-Genge, or you can say this is E2 pentene, right? Or you can call it N-Genge. So that is basically how to name this compound. It's called N-Genge. This Z is called Susame. Alright, so that is that. Let's look at the next one. The next compound you are given is this CH3. Draw the E and Z configuration. For CH3, CH2, C, Cl, double bond, CH, CH2, CH3. Now, if you are given something to draw like this, I told you that the first attempt is to draw the carbon-carbon double bond, and then from there we pick it up. So this will be carbon-carbon double bond, which is this. Now, this carbon here, what was attached under here? What do you have? Cl, right? Why this one? What do you have here? CH2, CH3. So you have it as CH3, then we'll have it as what? CH2, right? Then you have this carbon. What do you have here attached to this carbon? Hydrogen, right? What other group do you have attached? After the hydrogen is what? CH2, CH3. So you have this as CH2, CH3. Now, according to what I told you, what do? You use the invisible I, divide this into 2. Consider this part, consider this part. Now, listen, and listen very well. If you are given something like this, which of them do you think have the highest priority? Because this thing you see here means carbon. This CH3, CH2 means carbon bonded to how many hydrogen? 2 hydrogen. Because carbon will always bond with carbon. Are you getting it? Then you have these 2 hydrogen. Not the hydrogen bonded to carbon. Are you getting it? Then this other carbon is bonded to what? This carbon. And then you have how many hydrogens around it? 3 hydrogen. Now, between carbon, what you look to assign priority is the group directly attached to the double bond. Between this carbon and this chlorine, which will have the highest atomic mass, atomic number, rather. Chlorine have a higher atomic number than carbon. So chlorine will be A, while this carbon will be what? B, right? Right? And then this one, hydrogen here, and this carbon here. This carbon here, you see here, it means carbon bonded to hydrogen, then carbon again, hydrogen, hydrogen, hydrogen. Now, between this hydrogen and this carbon, which will have the highest priority? Carbon. So here will be A, while here will be what? B. So the isomer, what isomer is this one? Cis or trans? This will be, E or Z. Because the 2 highest priority group are on the same side, this will be the Z isomer. So we say this is Z. The name of this compound is 3-chlorohexene. 3-chlorohes. 3-ene, which is 1, 2, 3, 4, 5, 6. Here's what? 3-ene. Yeah. This 3-chloro is correct now. At position number 3, you have chloro group, right? And then you have 1, 2, 3. That's where you also have the double bond. Is that okay? So this is the Z isomer. Now, how do we draw the E isomer? I told you that the E isomer is just an inversion of the what? Z. So this one, we can decide to invert any one of them, CH2, CH3. I can decide to bring this chlorine up, and then let here be what? CH3, CH2. Such a way that here will be my A, here will be B, here will be B, here will be what? A. 2 high priority group are on different sides, so this become E3-chlorohes. 3-ene. Like I told you that this E and Z isomerism was given by a man called what? By 3 men called Kahn, Ingold, and Prelog. 3 different men, Christopher Kahn and the rest. Kahn, Ingold, Prelog nomenclature. So that is that for this particular one. Now let us examine another one. I believe this one is like the assignment that was given to us, and that is what is going to set. The only thing he did was to change the chlorine to what? Iron. So let's see. Are you done with this? You done? Good. All right. So this is going to give us, say, draw the E and Z isomer for CH3. I wouldn't want us to name this one because the naming is going to be just wasting our time. What we are concerned about is it the E isomer or the Z isomer? So we have CH2, we have C, double bond. What do we have here? CH3, CH2, then we have C, CH2, Cl, then we have CH, CH3, and then CH3. Now we are asked to name this using the E and Z nomenclature. How do we go about this? Name this using the E and Z nomenclature. How do we go about this? In Christ alone. Okay, the first thing we need to do here is first of all to draw the carbon, double bond carbon, and that is found here. Are you getting it now? So this is the first thing we need to do. We come here and draw this one as what? I'm going to draw it in such a way that CC. Then to this side, what do you think is attached here? You have what? CH3, CH2, right? To this carbon. So you have it as CH2, CH3. Now to this other side, what do you have attached? You have it as CH2, 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 and here is what? CH3. Abi? And then to this other side, what do you have here? You have CH2, Cl. Why to this one? What you have here is CH. Now this CH, what do you think is bonded to this CH at this side? You have CH3 bonded to it. True or false? Because if you look at it, now this CH, now they bonded to this carbon, which is this CH. Then to this CH, you have CH bonded to this side. Then this side, what do you have? Another CH3. Abi? Now, how do you name this particular one now? Now, listen. To straight chain alkanes that are not, so the first thing we have to divide this into two, right? Now, to straight chain alkanes that are not substituted and they are not branched, the longest chain usually have the highest priority. Is that okay? To straight chain alkanes that are not substituted and they are not branched, the longest chain usually have the highest priority. So long as it's just a straight chain, it is not branched too. So between these two here, which do you think will have the highest priority? Because this is a straight chain. This is also a straight chain. They are not branched. The longest one will have the highest priority. So this will have the highest priority. Why this will be our B. Now let us consider these two. Which of them do you think will have the highest priority? Is it this or this? Now we have to consider it. Now one way I would love to do this is to draw all the atoms that are actually bonded here. Are you getting it? Now what do you have here? You have carbon. Then after carbon, what do you have? Hydrogen. Then the hydrogen, what else do you have? You have another hydrogen bonded. Abi? Then what do you have at this place? Chlorine. Right? How about this one? What do you have? Carbon. Here is carbon. Then what do you have bonded to this carbon? Hydrogen. This other part here, what do you have bonded? CH3. And then what? CH3. Now, if you look at this one very well, between this carbon and chlorine, and carbon and carbon. Now, you cannot use carbon to determine the one with the highest priority, right? So you can strike out the carbon. So you go to the next atom. The next atom here is what? Carbon, right? The next atom here is what? Chlorine. So between chlorine and carbon, which one have the highest priority? Chlorine. Are you getting it now? So chlorine, this one here will be A, while this one here will be what? B. So what configuration is this? Is it the E configuration or the Z configuration? The Z. So you come here and say this is Z. So this becomes Z. Z. The naming, you don't need to bother about that. Just write it Z configuration because this one is somehow difficult to name. It's not difficult, but I don't want us to waste our time on that. So that is Z configuration. Now we can actually get the E configuration just by what? By inverting it. By inverting any one of them here. So we have something like C double bond C, and then we can decide to invert this one. Then you have CH3, CH3, then we have CH2, Cl, then you have CH3, CH2, 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 and here is what? CH3, CH2. So from here, what do we have here? Here will be A, here is what? B. Here is A, here is what? B. So what configuration is this? This is the E configuration. Is that okay? I believe that is clear enough. So any question that is given to you, I believe you should be able to attempt it using this idea. Now let's see the assignment that was given and see if we'll be able to answer it using this idea. Now the assignment that was given to us is, yes, the assignment they've given to what I was given to us is something like this: H3C, then we have CH2, CH2, and then we have CH2, and then here what you have is C double bond C, and then here you have CH2. The only thing they changed here is that iodine was added here instead of CH3, and then you have CH2. Instead of chlorine we have fluorine here, and then here you have C H, and then here H3C, still the same thing as CH3. Now the first thing we have to do here is to identify the what? The carbon-carbon double bond. We must have identified the carbon-carbon double bond, so now draw our structure for the E and Z nomenclature. Right? Now how do we do that? You first of all draw carbon-carbon bond. Now to this side, what is attached is what? CH2F. To this side, what do we have attached is CH. Then what you have here is what? CH3, which is H3C2. Then we have CH3. And then to the upside, what you have attached is CH2, 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 and here is H3C, which is the same thing as what? CH3. And then here, what you have is CH2I. Now let us assign priority to each of the individual groups that we have there. Between these two, which of them do you think have the highest priority? Between these two groups, which do you think have the highest priority? Now you cannot really just look at the one that have the highest priority here, because this CH3, CH2, 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 we have a lower priority as compared to this one. Do you know why? Because if you want to count it, you have CH2 here. This CH2 means carbon bonded to what? Hydrogen to what? Hydrogen, right? Why this one? The same thing, carbon bonded to what? Hydrogen to what? Hydrogen. And then the next atom that is bonded here is another carbon, true or false, which is carbon. Why this one? The next atom that is bonded here is what? Iodine. Now since this HC and this, they are the same, you can't use this group to note the priority. So what are you going to use now? Iodine or what? Carbon. Iodine have a higher atomic mass, atomic number than what? Carbon. So this group here will be our A, while this group here will be our what? B, right? Now coming here, the same thing is applicable. What did we say in the previous one? That this CH2F means what? C, hydrogen, hydrogen, and what? Fluorine. Why this one here means what? C, hydrogen, carbon, and what? Carbon, which is CH3, CH3, right? That's the meaning of this. Now between this carbon and this carbon, you can't determine the priority, so these two can cancel out. Now however, what you have here is what? Fluorine. Then this other group here, what you have here is what? Carbon. Between fluorine and carbon, which will have the highest priority? Fluorine. So it means here will be what? A, while here will be what? B. Right? So which configuration is this one now? This, you call it the what configuration is this? BBAA. This is what? E configuration. Right? So you call this the E configuration. Now, how do we draw the Z isomer for this? Told you that the Z isomer is drawn by just changing one or two of the stuff there. So to draw the Z isomer, we have C double bonded to C, we have CH2F, and then here you have CH, CH3, CH3. Now what I'm going to do here is to interchange this. Let this one be CH2I, and then let this one be CH3, CH2, CH2, and CH2. Right? Exactly. So at the end of the day, this one here is called what? A. This is B. Here is A. Here is B. So that at the end of the day, what configuration are we going to say is this configuration here? This one is the Z isomer. Or Z configuration. Alright? So that's basically how to go about this. Alright, so let's see another question. This one is going to, we should take note of them. So now that you've been able to do all these ones, every other thing, you should be able to run through them together. Now, we have another one that says triple bond CH, and then we have C, CH3, and then 3, and then we have CH, double bond O, and then you have CH2, here is CH2, and then here is OH. And you are asked to draw the E and Z isomer for this. Now, how do you draw this? It's very easy, right? Now, the first thing we need to do is identify our point. Will it be this triple bond or double bond? It must always be the what? Double bond. Are you getting it now? So this will be C, double bonded to C. Then to this C, what do you have? Triple bonded to what? CH. Then to this one, you have C. Now, this CH3 into 3 places means CH3, CH3, and what? CH3. That is the meaning. And then you have this CH. This CH, you can also arrange it as C, doubly bonded to O, and then you have what? H, right? And then you have CH2, CH2, OH, right? Exactly. Now, how do we name this compound? Firstly, we have to divide this by invisible I. Now, note something. Note something. There's something I want to tell you. Now, whenever you have C triple bond or double bond, anytime like that, this C triple bond means C bonded to carbon, this same C bonded to another carbon, and this same C bonded to what? Another carbon. That's the meaning of this. Are you getting it now? So it means that each of these, you consider them as bonded what? Separately. Do you understand that? And then you have this other side too. So our priority now is between these two. Which of them do you think we have the higher priority? Which of them do you think we have the higher priority? Now looking at this very well. Look at this C, carbon, carbon, carbon. Same thing is what you can see here. Right? C, carbon, carbon, carbon. Then you have this one hydrogen, one hydrogen, one hydrogen. Then this one is for 3 hydrogen, 3 hydrogen, 3 hydrogen. So which of them do you think will have the highest priority? The one under, right? And then this one will be what? B, right? And then the next one is this. Now, like I told you, this carbon here means carbon bonded to oxygen, bonded to what? Another oxygen, and then you have what? Hydrogen. Why this one here means carbon bonded to what? Hydrogen bonded to what? Hydrogen, right? And then this one, carbon bonded to what? Hydrogen to what? Hydrogen. And then what do you have? OH. So which of them do you think will have the higher priority? This carbon here is bonded to 2 oxygen. Why this carbon here is bonded to what? 2 hydrogen. Of course, if you cannot use carbon to determine the priority, you are now going to use oxygen and what? Hydrogen to determine the priority. This oxygen has a higher atomic number than what? Hydrogen. So it means this one will be A, while here will be what? B. So what configuration is this? What configuration is this? This is Z configuration. So you can come here, say this is the Z configuration. So this is Z configuration. Now, how do you think we can draw the E configuration? By just substituting. To draw the E configuration is by just what? Changing the substituents around the carbon atom. So you have carbon bonded to carbon. I can decide to bring this one up, and then what do I have here? This carbon. You know, this carbon we are told is bonded to what? CH3, right? And then this one is carbon triple bond CH. And then here is CH2 OH. And then you have this carbon doubly bonded to oxygen and hydrogen. So if you look at this, this is A, this is B. This here is B. Okay, this is A, yeah, and this is B. What configuration is this? E configuration. This is the E configuration. Is that okay? So that is that. Alright, so the next one is assign relative priority to each of the following. When we mean relative priority, we mean which of them have higher priority than the other based on what we have learned. Now, you have B arrow, right? You have iodine, you have OH negative, and then you have CH3. Which of them do you think will have the highest priority? Higher priority is based on the one with the highest atomic number, right? So iodine have the highest priority. So you can come here and say iodine is greater than, after iodine, the next one is what? Bromine, right? Which is greater than, the next one here is what? Oxygen, OH, which is of course greater than what? CH3. Are you getting it now? Because carbon is the least element here in the periodic table. Do you understand that? Alright, so the next one is B. Let's assign priority to these ones. CH3. No, CH2 is CH2 because it's a substituent. CH2OH, and then you have OH, and then you have CH2Cl, then you have CH double bond CH2. Assign priority to each of these. Which of them do you think have the higher priority as compared to this? Now, let us look at them carefully. What do you have here? Each of the first atom here. Carbon, oxygen, carbon, carbon. Are you getting it now? So oxygen, you have OH. Then coming here is greater than. Which of them do you think will follow next? After this carbon here, what do we have? Alright, so this one will follow next. From our understanding, it means this one will be in the next, right? Because if you consider this is like carbon bonded to what? Hydrogen to hydrogen and to what? Chlorine, right? And carbon and chlorine, this chlorine bond have higher priority than any other carbon bond you have here. So which of them will be the next? This, which is CH2Cl. After this, which of them will be the next? this one, right? Do you know why this one will be the next? Because you have, if you consider this one is like, this particular one here is like carbon bonded to what? Hydrogen to hydrogen. Then before you have carbon to hydrogen, then you have what? OH. Consider it from this side. Now how about this one? This one means carbon, then to hydrogen. Are you getting it? Then to what? Carbon, and then to what? Carbon. That is the meaning, because I told you that H double bond, you consider it as a separate bond entirely. We'll have H2 and what? H2. True or false? Now if you want to consider now, here you have carbon. Here you have carbon. What is this carbon bonded to? Here. Hydrogen. So this hydrogen cancel this hydrogen. This other carbon here, what do you think is bonded to this side? It's bonded to carbon here. So this carbon can cancel this carbon. Abi? Then the next one here, what is it bonded to? Hydrogen. Why this one is bonded to what? Carbon. So it means this one have the higher priority than that. So you have this one, which is CH2, and then you have that CH double bond CH2 greater than the next one. Is the last one is particularly this one, which is CH2 OH. Are you getting it now? So this is the correct arrangement in order of priority. So basically that is everything you need to know about the E and Z configuration. By this, we've been able to come to the ending of the E and Z configuration. Thank you very much for your time. We'll see you in the next one.